Hey guys, this is Mr. Lowry. I wanted to give you some help and some hints on this assignment applying real number properties because some of these questions are a little bit tricky. What I would have out while you're working on this assignment is your real properties of real numbers assignment from earlier this week. The first step was just figuring out what all those properties are, and now we're actually going to start applying those properties here. Okay? So the first question here asks us what property of multiplication allows us to simplify fractions by canceling out. Okay? So there's a property that looks something like this. A over A equals 1. Okay? Or sometimes it's written A times 1 over A equals 1. But this is the same idea. Okay, the idea is if you have something over itself, you're going to get 1, right? 5 over 5 is equal to 1. 3 over 3 is equal to 1. 2 over 2 is equal to 1. That kind of allows us to simplify these fractions. So this property that we're using right here is called the multiplicative identity property. Okay, so we're going to apply that in these here to simplify these fractions. Now, simplifying fractions is something you probably already have done before, but what we're trying to do here is we're trying to pinpoint at what point do we see this property come into play, or why can we simplify it? We know how to simplify it. The question is why. And this will actually set us up for some more properties that we're going to get later on in the next couple weeks. So let's take a look at number 2. Okay. Now, what we're trying to do when we're simplifying a fraction is we're trying to find anything where it's a number over itself. And if we can do that, we can say, okay, well, that's just 1. So if you think about 44 and 100, those aren't the same number, right? But there's some of the same numbers inside of them as what we call factors. So 44, if we break that down into factors or pieces, when we're talking about multiplication, we can find some common factors. So 4 goes into 44, and it also goes into 100. So we're going to call the 4 our common factor. Yeah, we actually want to find the biggest one possible. So 2 is also a common factor because 2 goes into both of those. But 4 is the biggest one. We call that the greatest common factor. So I can rewrite this 44 as 11 times 4. Those are both factors of 44. They're numbers that multiply to 44. Okay, so 44 I can write as 11 times 4. On the bottom, I'm going to write 25 times 4. And what I'm looking for, again, is common factors. So I can see that 4 go into both of those. Now notice here that now I have a 4 over 4. So typically what we would say at this point is that these cancel. Okay, what we really mean by that is that these are a 1. This 4 over 4 is actually equal to 1. And a lot of times when we're multiplying, and we're multiplying by 1, we don't really need to write that 1. So when we cancel this 4 over 4 out, we really have 11 over 25 times 1, but we don't really need to put that 1 anymore. So this is our simplified fraction. Okay, so notice how we use that multiplicative identity property. Sorry, let me go back. This is actually called the multiplicative inverse property. Sorry about that. Those properties are actually really, really similar. They are kind of two sides of the same coin. They go together. Inverse is what allows you to cancel. The multiplicative identity property is actually multiplying by 1, which we'll actually use a little bit later. So sorry about that. This is the multiplicative inverse property. Okay. Let's take a look at a couple more of these. We're not going to do all of them, but we're going to look at several examples. Okay, now this one just says A over A equals. Well, that's just equal to 1. There's not a lot of work to show there because it's basically the property, right? Anything over itself is equal to 1 as long as that anything isn't 0. So we're going to assume for this assignment that the variables aren't equal to 0. Okay, now if we take that idea and we apply it over here, we can kind of use the same process, right? When you see something new that has variables or looks a little bit different, that can be a little scary. But if you know these properties really well, it doesn't really change the problem that much. It's actually the same kind of problem. So let's take a look. What does 6 times x actually mean? Or excuse me, what does 6x actually mean? It means 6 times x, right? Okay, so we know that this is a 6 and an x. Well, what about the bottom? Okay, well 12x is 12 times x. right? Do we see any common factors yet? Notice we have an x over x. If a over a is equal to 1, then shouldn't x over x also be equal to 1? The answer is yes, they should. Okay. Now we have other common factors with the numbers as well. So think to yourself for a second, what goes into 6 and 12? Well, 2 goes into both of those, and 3 goes into both of those. Okay, but what's the biggest thing? What's the greatest common factor? The biggest thing that goes into both of them is actually 6. So I can write this as 6 times 1 times x, right? And on the bottom, I can write this as 6 times 2 times x, okay? 6 times 2 is 12, 6 times 1 is 6, and now we can see that common factor. What goes into 6 and 12? 6 does. So you can see that 6 over 6 right here. So 6 over 6 is equal to 1. So we cross it out because it's equal to 1. Okay, x over x, also equal to 1. We cross it out because it's equal to 1. Okay, and then we have 1 over 2 left over. So even though this had variables in it, which is a little bit new, a little bit scary maybe, it's really the same process as what we did over here. We're just looking for common factors. We're looking for a over a, or 4 over 4, or 6 over 6, or x over x. We're looking for things that we can turn into ones, or that we can cancel or cross out. So that's kind of how those problems work. There's one more for you to do, and you're just going to kind of do it the same way. Find the common factor. Show me that you're using this property by writing it out like this. Okay. What property of multiplication says if you multiply a number by 1 or a form of 1, you get back the same value? Okay, that's the one I actually had up here originally. So this one is inverse. This is correct. A over a equals 1. Or a times 1 over a is equal to 1. Okay. This one right here is a very similar property, but kind of looking at it from a different perspective. This is the multiplicative identity property. Okay. You can also call it the identity property of multiplication. So multiplicative means we're talking about multiplication. So we have a multiplicative inverse property, we have a multiplicative identity property. Okay, and again, this just looks something like this. A times 1 equals A. Okay, so notice that these are actually really, really similar statements. In fact, if we rearrange this equation, we get this one, and if we rearrange this equation, we get this one. For example, if I were to just divide both sides by A here, right, I get 1 equals A over A, which is basically what I have here. So these properties are really just the same idea from two different perspectives. Okay, what property of multiplication are you using when you multiply the numerator and denominator of a fraction by the same number to change the denominator? Give an example. Before we tackle that one, let's look at this fraction in number 8 and how we would do this. Okay, we know we need common denominators here. So we have 2/3 and we have 1 over 6, and we need to have, sorry, my computer's beeping at me, just a second. Okay, we need to get common denominators. Let me zoom in a little bit so you can see the fraction a little bit better. Okay, what we need to do is we need to multiply this fraction by 2 over 2. Okay, that's going to change it into a 4 over 6. 2 times 2 is 4, 2 times 3 is 6, and now I have common denominators. Okay, we know that that's the process. When we're finally done, we keep the common denominator on the bottom, and then we add the top. 4 plus 1 is 5, and so we got 5/6. Now think about this for a second. Going back to the property we just talked about, what is 2 over 2? Okay, 2 over 2 is equal to 1, right? So really what I'm doing is I'm multiplying by 1. The multiplicative identity property says if I multiply something by 1, it doesn't change, right? So 5 times 1 equals 5. Okay, big deal. Well, when we apply it this way, 2/3 times 2 over 2 is equal to 4 over 6, right? The question is, how is that possible? How does that work? How do we know that these two are the same exact thing? Well, because this is actually 1. So this is just an extension or an application of the multiplicative identity property. Okay, we're multiplying by 1 right here. So think about it like this. Here, we're trying to cancel common factors. Okay, that uses the inverse property. Here, we're kind of like unsimplifying, right? We went from 2/3, which is simple, to 4/6, which is actually less simple. It's less simplified, okay? So that's kind of what's happening. We're unsimplifying this fraction. And the reason why we're unsimplifying it is so that we have common denominators. So this is our answer here. Okay, now if we go back up here to number 7, now we know we're talking about the multiplicative identity. Okay, so we're going to make up a problem kind of similar to what we saw in number 8. So let's just make up two fractions that don't have common denominators. Kind of make sure they're in simplest form. So let's just do this one. Okay, 3/4 plus 1/3. We got to get common denominators, right? So we have to make this one and this one the same. We got to figure out what number those both go into, and we want to pick the lowest one. 3 and 4 both go into 12, so that's called the lowest common denominator. Okay, we want both of these denominators to be a 12. To get this denominator to be a 12, I'm going to multiply by 3. I have to multiply by 3 on top, though, because this needs to be 1. It needs to be a form of 1 that I'm multiplying by, so that I actually don't change the value of this fraction. Okay, now this guy, I need to be a 12 as well, so I'm going to multiply it by 4. Have to multiply it by 4 over 4, again, because this needs to be 1, so that I'm not changing the value of the fraction. Okay, so I'm multiplying by 1, multiplying by 1. That's going to give me equivalent fractions. 9/12 for this guy, plus 4/12 for this guy. Okay, when we put those together, we have the common denominator 12, and then 9 plus 4 is 13. And we're going to leave this as an improper fraction. As long as it's simplified, that's good. In algebra, we use simplified improper fractions because mixed numbers, like this would be 1 and 1/12, get really messy when we start having variables involved. Okay, so this is an example of really multiplying something by 1. If I take 3/4 and I multiply it by 1, I get an equivalent fraction because something times 1 should be itself. And when I take 1/3 and I multiply it by 1, right, 4 over 4 is 1, I get an equivalent fraction because 1/3 times 1 is itself. So 4/12 is the same as 1/3. 9/12 is the same as 3/4. We get those equivalent fractions. Okay? All right, let's look at the one with the variable. Okay? Again, the idea here is if we can remember and apply the property of equality or a property of multiplication or whatever, property of real numbers, then we can do it. We can go ahead and do that. Sometimes you see stuff that's new and you're wondering, like, what do I do here? Well, see if there's a property you can apply. Okay? Now we need these to be common denominators, just like we did before. So what does this guy have that this guy doesn't? Well, this is an x and this is a 2. So we need to have a 2 over here, so that because this guy has a 2. So I'm going to multiply by 2 over 2. Again, this is using the identity property because 2 over 2 is equal to 1. Okay, so that if we kind of figure out what that's going to be 2 times 3, which is 6, over 2 times x, which is 2x. So that's this guy. I took this fraction and I multiplied it by 1, and I got an equivalent fraction. We need to do the same thing with this guy. Okay, now this common denominator that we have, or this fraction that we have, we need common denominators. So what does this guy have that this guy doesn't? Okay, well this guy has an x, so we need an x over here. We're going to get that by multiplying the bottom by x. We have to make sure, though, that we multiply by a form of 1. So x over x is equal to 1. So we're actually multiplying it by 1. So 6 over 2x plus 1 times x is x, 2 times x is 2x. Okay, now we got common denominators. Whenever we're adding fractions and we have common denominators, the final answer will have that common denominator. So in this case, our final answer is going to have a 2x on the bottom. Just like over here, when we had the common denominator 6's, we had a 6 on the bottom. Okay, now for the tops, we just need to add 6 plus x. So we have to ask ourselves, well, what is 6 plus x? Can we simplify that? If you're thinking, okay, maybe 6x, well, 6x is actually 6 times x. So we actually want to just write 6 plus x because there's no way to simplify this. 6 plus x is just 6 plus x. Since these are not like terms, we can't really combine them, but we can put them over the common denominator. Okay, so this is as far as we're going to go. All right. What property of addition allows us to rearrange terms in an expression? Well, let me give you an example. Let's say we have 3 minus 7. Okay? Looks like a subtraction problem. I can rewrite this as 3 plus negative 7, right? And then if I want to, I can rearrange those terms or those pieces, and I can say 3 plus negative 7 is the same thing as negative 7 plus 3. In all cases, we're going to get a negative 4 out of this. Okay? The property that allows us to rearrange the terms in an addition problem or a subtraction problem is called the commutative property of addition. Now you got to be careful here because there is also a commutative property of multiplication. And we want the property of addition because that's what we're talking about. Okay? When we're talking about terms in an expression, we're talking about pieces that are separated by addition and subtraction signs. Okay? So let's take a look at an expression that has terms in it. Okay, so here's an expression that has terms in it. Okay, we got some x stuff, we got some regular numbers here. Okay, the terms are separated by the plus and minus signs. Okay, this is called an expression with terms. We usually use this phrase, combine like terms. Okay, and what that means is find the ones that are similar and put those ones together. What we're doing in our heads when we do that, without maybe even knowing it sometimes, is we're reordering it. So we can put the 3x and the 5x and the negative 10x all next to each other, and we can put the negative 2 and the negative 3 next to each other. Okay? We don't always write that out. For this assignment we will because we're trying to show properties of real numbers. But these guys, we can rearrange this and put them next to each other. And then we can combine just these guys because these are the like terms. They all have an x in them. So if I have 3 x's and 5 x's, that's 8 together. And then I have a negative 10. 8 and negative 10 together are going to give me a negative 2. So I have negative 2 x's. These guys are similar to each other. They're both numbers without x's. We call those constants. And we can put those guys together. A negative 2 and a negative 3 together is going to give us a negative 5. Okay? I can't go any further here because this doesn't have an x, and this isn't a regular number. These are not like terms. And so this is as far as I can go in simplifying this expression. Okay, the question is, what property did I use? We know how to combine like terms, but what is it that allows us to say that I can add these 3 numbers together and just skip over the other numbers? It's the commutative property of addition. Okay? So I'm going to let you try this one on your own. Just follow the same pattern. But that's the property that we're using. Okay, next one. What property of equality allows you to replace an expression with something that's equal to it? Okay? Well, when you replace something, another word for replace is substitute. Okay? So this is actually the substitution property of equality. So that word replace is kind of a synonym for substitute. Okay? So if I have 2 things that I know are equal, I can replace something with that thing. So let me give you an example of how we see that sometimes. Okay, so if I know a is equal to 5, and then I see this expression 3a plus 2, what I can do is I can say, okay, if a is equal to 5, I can replace that a with 5, and now I can evaluate. Evaluate means do the operations in order until you get a number. Okay, so 3 times 5 is 15, and then 15 plus 2 is 17. Okay, so that's substitution. When you know a is equal to 5, you can replace a with 5. Okay, the same thing's going to happen here, but it's going to be a little bit more complicated. So in Secondary Math 1, you guys learned how to solve systems of equations with 2 variables in it. Okay, let's take a look at this one. Right now, this says x is equal to 6y minus 20. What that means is whenever I see an x, I can replace it with 6y minus 20 because they're equivalent. Just like I replaced a with 5, I can replace x with this thing. So if I look at the second equation, anytime I see an x, I can replace that x with 6y minus 20. Let's try it out. So I have negative 8 times x. Okay, we just ran into an x. So instead of that x right there, next to that negative 8, I'm going to write 6y minus 20. I'm going to put it in parentheses so I don't forget to distribute. And then I'm going to finish writing the rest of the equation. So this second equation used to say negative 8 times x minus 7 times y equals negative 5. And now it says negative 8 times this stuff minus 7 times y equals negative 5. So I just rewrote this thing and I replaced the x with what x is equal to. What's the benefit of doing that? Well, notice when I started, I have an x and a y. And it's really hard to solve for a variable if there's more than one variable. Okay, now I don't have x's and y's anymore. I've replaced the x with some stuff that has y's in it. And now it's only y's and I can solve for y. So let's just keep going. I'm going to distribute. Okay, now I'm going to combine like terms. The like terms are these guys. So that's negative 55y plus 160 equals negative 5. Okay, now I kind of I did a mental step here, right? Really, what's happening is I'm reordering these so that this is next to this, and then I can put them together. I usually jump over that step when I'm actually doing a problem, but kind of hidden here was the commutative property of multiplication or of addition. So I kind of rearranged the terms in my mind so that they were next to each other. I kind of grouped them that way and put the y's together. Okay, from here I'm going to use the subtraction property of equality. Subtract 160 from both sides. These two cancel because they're additive inverses. 60 and negative 160 together give you 0. So when I cross that out, really what I'm saying is I have 0 here. Okay, combine these guys. Now I'm going to divide both sides by 55, or negative 55, excuse me. Cross those out. Now, this is kind of interesting. I canceled these, and that meant that I had 0 because it was add and subtract. Here, I have multiply and divide. Multiply by negative 55 and divide by negative 55. When I cancel here, I actually get a 1. That's the multiplicative inverse property. So 1y equals, and this is going to come out as a positive 3. Okay, we're not done yet. We got to take that 3 and we got to find out what x is. So now that we have y, we need to come back up to the top and solve for x. So if I take the first equation, x equals 6 times y minus 20. Now that I know what y is equal to, I'm doing another substitution. I'm replacing that variable y with what I know it's equal to. So this is 6y minus 20, but instead of y I wrote 3. So x is equal to 18 minus 20, because that's going to be 6 times 3 is going to be 18. And then I'm going to finish off. 18 minus 20 is negative 2. Okay, so I have two values, and my final answer here is going to be negative 2, 3. Remember, the solution to a system of linear equations is a coordinate. It's where those two lines intersect. Okay, so that should give you some help on 17. 16 is really similar. The only difference is you're going to replace the y. Okay, I'll get you started on this one. So I'm going to rewrite this guy, 3x minus 6 times y. But since I know what y is equal to, I'm going to replace that y with negative 4x minus 15. So I have 3x minus 6 times. This time, this over here, it's multiplied by y. Over here, it's multiplied by what y is equal to. Equals 9. Okay, now from here, you can distribute the negative 6, combine like terms, solve the equation. You're going to get x equals a number. Then you're going to have to substitute again, plug it back into there, and you can find out what y is. Okay? All right, moving right along. Okay, now this is kind of what we just did. So we're going to solve like a multi-step equation, but we're going to try to keep track of all the properties that we're using at each step, all right? Now, I actually kind of made a mistake here. I'm sorry about that. This little cross out should actually be right here, okay, when we cross these guys out. So I'm going to rewrite this one here just so you know what it should have been. I just crossed out the right one. Otherwise, these steps look really similar. But I'm going to have 30 plus 2, negative 30 plus 2n equals 7n minus 10, and then minus 2n, and then minus 2n. Okay, that's what it should look like. And then this is the step where I actually cross out the 2n's. Okay, so now that we have that kind of fixed, let's go through and talk about these properties. Now, typically when we solve a problem like this, we don't write out every single step. We write out some of them, right? Some of the things we kind of do in our head, but the reason why this is all broken out is so that you can really see all the properties that you're using at once. Okay, so how do we get from here to here? What's happening? Well, we got rid of the parentheses, right? The parentheses are gone. What happened there is I multiplied the 2 by the negative 5 to get negative 10, and I multiplied the 2 by that n to get 2n. So I distributed, right? So this is the distributive property of multiplication. Okay, I'm going to use some abbreviations here. You're welcome to do the same thing as long as it's clear what property you're talking about. Remember that there's many properties of multiplication, there's many properties of addition, and there's many properties of equality. So you need to be specific with what property you're talking about. Okay, this is abbreviated, but it's still specific enough that we know what's going on. Okay, now what's happening from here to here? Well, notice that the 2n is now in the middle. So this side has been rearranged. Okay, we rearranged the terms in that expression. Okay, that is the commutative property that we talked about. Now remember, there's a commutative property of multiplication and there's a commutative property of addition. Okay, this one that we're talking about here is the commutative property of addition because we have addition and subtraction going on here. Okay, let's look what happens next. Okay, these guys get combined to a 7n. Now this one's kind of tricky. We would call this step combine like terms. Okay, but there's not a combine like terms strategy. Property. There's not a combine like terms property. So what we're going to have to do here is we're going to have to figure out what's happening and figure out what property we can say. What we're really doing is we're replacing 5n plus 2n with 7n, which is what it's equal to. Okay, so this is kind of a stretch here, but the property that really is going on is the substitution property. We're replacing, so let me write substitution property of equality. We are replacing 5n plus 2n with what it's equal to, which is 7n. Okay, so whenever you're combining like terms and you're trying to figure out what property that is, it's probably a combination of commutative property, because you're rearranging terms in your head usually, and the substitution property because you're replacing those terms with what they're equal to. Okay? All right, let's keep going. From here, we want to group all the n's, and there's n's on the left and there's n's on the right. We already combined the n's that were on the right, but now we have to kind of get all the n's on one side of the equation. So in this case, what we would do is we would subtract 2n from both sides. Okay. Now we got to kind of break this up into pieces. Normally we would cross that out right here, but there's two properties going on and we want to catch them both. The first property that says we can subtract the same thing from both sides of an equation is the subtraction property of equality. Okay, so again, I'm abbreviating a little bit. You're welcome to do that as long as you're being clear on what the property is. Okay, so that's the subtraction property of equality. I'm keeping it balanced. Okay, now this is this is kind of the tricky part. The next step we would do is we would cross these out, which is what I tried to show here, but I had it in the wrong order. So we're going to cross those out. But what do we mean when that happens? What's actually happening here? What does the cross out mean? Well, it kind of means it's gone, right? We don't have to deal with it. But what's happening here is that 2n and negative 2n, when put together, give you 0. Okay, so just kind of down here, let's think about something for a second. 5 plus negative 5 is equal to 0. 2 plus negative 2 is equal to 0. So 2n plus negative 2n is equal to 0. These are what we call additive inverses. We have 5 and its opposite. We have 2 and its opposite. We have 2n and its opposite. When we combine opposites with addition, we get 0. Okay, that's the additive inverse property. Additive inverse property says something like this. A, any number, plus negative a, its opposite, is going to result in 0. Okay? So when we cross these out and we say cancel, really what we mean is that this is equal to 0, and so we don't really have to write it anymore. So this is the additive, sorry, not identity, inverse property. Or you could call it the inverse property of addition. Remember that there's an inverse property for addition and there's an inverse property for multiplication. We're going to see them both in this problem. All right, so we canceled those out and we're down to here, okay? So on this side, we canceled. On this side, we basically combined like terms again, right? We replaced 7n and minus 2n with 5n, which is what they're equal to. So I'm going to go back and call this the substitution prop of equality. That's just the bell to leave school, so sorry about that. All right, cool, so we're still going. Okay, now we got to get the numbers all together, right? So notice that we're going to add 10 on both sides to get rid of this 10. So the fact that we can add the same number to both sides of an equation and it stays equal is the addition property of equality. Okay? Now here they get canceled, right? So that's the step. It's the same exact thing. They look identical, except now we've crossed this out. 10 and negative 10 are, again, additive inverses. They cancel out. But what we mean specifically by cancel out in this case is that we end up with 0. Okay, so this is the additive inverse property. Okay. Then what's happening is these are getting combined, right? Negative 30 plus 10 is negative 20. So we're replacing this expression with what it's equal to. So again, substitution prop of equality. Okay? Okay, now we're trying to get n by itself, right? So the next step is we have to divide both sides by 5 to undo that 5 times n. So we divide both sides by 5. Okay, that's the division property of equality. It says that we can divide both sides by the same thing. And the equation will still be true. What happens here is that the 5 over 5 cancels, right? But this is a different cancel than this, which is kind of tricky. In this case, when these cancel, we really mean they give us 0 because they're additive inverses. When these two cancel, really what we mean is we're going to get 1. So 5 over 5, let me zoom in a little bit so you can see. 5 over 5 is equal to 1, and that's why this is actually 1n. We don't usually write the 1 in front of it, but we know that that's 1n. Okay, over here, the same thing is happening. There is a 5 in negative 20. So the 5 in negative 20 is canceling out with the 5 that's on the bottom. So negative 20 is negative 4 times 5. So there's a common factor there. Same thing's happening. We're canceling out those common factors. So we're getting a negative 4 times 1, basically. right? So what allows us to cancel this way is a different property than this cancel. This cancel is an addition cancel, right? Addition, subtraction cancel. This is a multiplication division cancel. Okay, this gives us 0. This gives us a 1. It's a little bit different. So this is actually the multiplicative inverse. Okay? And then the last thing is, okay, we got -4 equals n, but we want to write it in the other direction. We usually write the variable first, so we just switch it around the other way. Okay, what property allows us to do that? There's a property that says if a equals b, then b equals a, right? That's called the symmetric property. It basically is saying if you have an equation, it doesn't really matter which order you write it in. You can kind of switch the sides around, and it's still the same thing. So this is the symmetric prop of equality. Okay? So there's that. Now, that looks like a lot of work, right? It's a lot of steps. Again, we don't normally write all of this stuff out. The point of this is to get you to see that how you use all of these properties, to get you to see that really you're using them all the time. And another really important thing to point out is that the word cancel is not a very good word to use because it means two different things. Sometimes cancel means you get a 0. Sometimes cancel means you end up with a 1. It all depends on if you're adding and subtracting or if you're multiplying and dividing. Addition and subtraction are opposites, but when you combine those opposites, you get a 0. Multiplication and division are kind of opposite as well. When those undo each other or work against each other, you actually end up with a 1. Okay, almost there. Okay, so we're going to look through this work here, and we're going to find the problem. When a student makes a mistake solving an equation, it's usually because they don't understand a property. They don't understand what they're doing. They're trying to remember a procedure. They're trying to memorize what you do every time, okay? But every equation's a little bit different, and so learning a procedure to memorize isn't as good of a method as just knowing properties that you can apply in any situation. So let's take a look at this one and see what's going on. Okay, we're going to find the error. So it looks like from here to here, we're distributing the -6. That looks okay. -6 times 8 is -48. -6 times -3x is positive 18x. That's cool. Okay, now it looks like we're trying to combine it looks like we see that these right here are both numbers and this is a variable. So this is actually what's going wrong here. Okay, plus 48 plus 48. It looks like they're trying to use the addition property of equality, but they're using it incorrectly. This is where the equal sign is. Can you add 48 to both sides of an equation? Yeah, absolutely, you can totally do that, right? But this is adding 48 on the same side of the equation twice. So you're actually not keeping these sides balanced. You just added 48 and 48. You just added 96 to the right side of the equation, and you didn't add it to the left side of the equation. Okay, so this is actually not correct. It looks like they want to get rid of that 48, but that's not what's going on here. Okay, so this is incorrect. This is the error right here. You can't add 48 here and 48 here because these are both on the same side of the equation, right? That's not applying the addition property of equality correctly. Okay, so let's fix it. Okay, so let's go back to this step. We have -2x plus 18 equals -48 plus 18x plus 6. Okay, now we notice again that these are both numbers. So instead of trying to add 48, or even subtract 6, because those are on the same side, we're just going to combine like terms. We're going to use the commutative property of addition, and we're going to rewrite this so that they're next to each other. Okay? Now it doesn't seem like they're on different sides of something. They're just right next to each other. We're just going to put them together. We're just going to combine them. What's -48 plus 6? It's -42. Okay? That's the problem. Okay, I see this a lot as a math teacher where people are trying to add 48 on the same side of the equation. And what that tells me is that these students don't understand the addition property of equality. So this is actually what we should have. We can keep going from here. I would start by grouping the x's. So add 2x to both sides, addition property of equality. These now are additive inverses, so they cancel, which really means I have 0 there. These we're going to replace with 20x. Okay. Now we're going to get all the number stuff on the left side. So I would add 42, add 42. Okay. Again, that's the addition property of equality. I'm going to cross this out. Okay. Really what I'm using is the additive inverse property. 42 and negative 42 together give you 0. Okay, over here, I'm going to get 60. Okay, and then the last property here is I'm going to divide both sides by 20. Okay, I'm using the division property of equality, and I get 3 equals x. Let's flip it around to be x equals 3. That's, again, the symmetric property of equality. Okay, so based on the work, what property does the student misunderstand? They misunderstand the addition property of equality, right? This idea that's like, oh, I can add the same thing to both sides. Yeah, you can, but it's the same to both sides of the equal sign, right? Not the same thing to the same side, right? Here they're adding 48 to the same side of the equation. They're not adding 48 on either side of the equal sign, so they don't understand the addition property of equality. What they really should do here is they should combine like terms, and then they should start using properties of equality from there, okay? So I would explain to the student here that if you want to add the same thing on both sides, you need to do it on either side of the equal sign. If the numbers are on the same side of the equal sign, you're not going to use this property. You're going to combine like terms, okay? All right, so that's most of it. There's a couple here that we didn't fully do. You guys can kind of write out what we talked about right now, put it in your own words. Again, the property that they messed up is probably the addition property of equality. It doesn't look like they understand that one very well, okay? Cool, so that should help you out if you got stuck there. If you have any other blanks that you don't quite understand, do your best, okay? Don't leave anything blank. Try something. You got all these properties to choose from. Try applying one of those properties. If you're wrong, at least you tried something, okay? What we don't want is we don't want students giving up and stopping to try just because they're a little bit stuck. Okay, so persevere, work hard, try to get in there. I hope that helps. Remember to submit via Canvas and then put this in your 3-ring binder. Thanks for watching.